As I mentioned yesterday, quadratics, such a vital thing in maths because all of those things can be factorised down to be a combination of quadratics and linears. Now, obviously, linear equations very easy to solve. So the other one is we would like to know how to solve quadratics. I guess the first idea we looked at with quadratics was this very basic idea. If you've got two things multiplied together to equal 0, one of those things at least must be 0. It's the only way you can multiply and get the answer of 0. So using that idea, if the quadratic can be factorised, then it's very easy to solve. So there's a simple one, x squared plus 9x plus 18 equals 0. We can factorise it, and so we know, hey, look, we've got two things multiplied together to 0. At least one of these things must be equal to 0. So therefore, either x is negative 6 or x is negative 3. A common mistake here, when we factorise and just have an x out the front, people sometimes think, oh, well, it's just x by itself, I don't have to worry about that. It's still a possibility, of course, that x could equal 0, but it's surprising how often people make a silly mistake and forget about including the solution, x equals 0. So, of course, this one, x equals 0 or x equals minus a half. So, all right, ones that can't be factorised, we created a quadratic formula for. And there it is in all its glory. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So, all right, let's go use our formula. 2x squared plus 5x minus 4. So we can't think of how to factorise this. So we plug it into our formula. 25 and 32 is, of course, 57. No, we don't know what the square root of 57 is. So that's the best we can do. That, of course, is what we call an exact answer. And in maths, we like exactness, preciseness. That's what maths is about, exact. Of course, if you're in science, you would go to your calculator because they like approximations. They're obsessed with knowing an actual number. They don't like square roots and things like that. Have you found that with science teachers? They always want you to... We get questions like this. Make x the subject. That's all right, we can do that. This is a quadratic equation. We just think of y, so the other pronumeral is there, like a constant number. That's all we think of. So if I rewrite that, my quadratic equation becomes x squared plus 4x minus 3 plus y equals 0. So if I want to make x the subject, it's just saying solve. So x equals negative b plus or minus square root b squared minus 4ac. It's just that c involves y all over 2a. And so there it is, tidy it up a bit and a bit more. And there we have it. There's x as the subject of that particular, formula. And in fact, what you're looking at, if you think about this as a graph, y equals x squared plus 4x minus 3 is a parabola. When we make x the subject, what we're talking about are the two halves of the parabola. That minus 2 is the axis of symmetry, and then we're saying, well, on the left-hand side, we would be going minus the square root of 7 plus y, and on the right-hand side, we'd be going plus the square root of 7 plus y. Okay, so there's 1g.